The command large data sampling is not our point cloud solution, but it will handle large DTM datasets and is available in LSS Vista and above. I have copied some Ordnance Survey Esri ASCII grid data files into a folder, and I've created a new empty survey in that same folder. I'm now going to select large data sampling, and I can browse for either a single or multiple Esri ASCII grid files, which is what I have, or single or multiple XYZ data files. The format of those XYZ data files just has to be eastings, northings and then level, but it can be tab, space or comma delimited. I'm going to browse for the folder that contains the Esri ASCII grid files, and I can either select all of them, or if I'm already in the correct folder I can just say all and it will find them all. So there are 20 files there. It now displays the geographical position of each of those tiles, and this is going to be the first part of the tutorial on data sampling. I'm going to look at how you restrict the geographical selection of data. If I just reduce the text size, we can then see the individual Esri ASCII grid tiles. And if I wish to limit the area of conversion, then I will select the lower left and the upper right. There are 3.2 million points within all of the tiles, but bear in mind that the Esri ASCII grid files are rectangles. In these cases they're squares, and some of the rectangles may contain areas that don't have any data in them. That 3.2 million doesn't include the fact that there may well be some missing data, so that's a worst case situation in that there may be fewer than 3.2 million. The whole set of data could be loaded into a single LSS survey, because a single survey can contain 4.08 million. But what we're trying to do here is reduce the amount of data geographically. The grid size is the same for every tile. It's 50 meters. If each tile had a different grid cell size, then they would all be listed here. And then we've got the maximum overall grid coordinates, which will be from lower left to upper right. We've decided to limit the area of conversion, and all things being equal, that will now reduce the number of points down to 1.7 million. If I select next, and I'm just going to choose finish from this dialog. This will now offer to create a new LSS load file, or an XYZ file, or in fact a PTS file. A PTS file is the type of file that a Leica scanner would produce. You would only really ever want to create an LSS load input file or an XYZ. We're going to load it into the current survey, so I don't need to define a load input file name. Next is now sampling that data, and it has created an LSS load file from that restricted selection of data, which I'm now going to load. And if I move this dialog away, you will see the points being loaded, restricted by this rectangle that I defined earlier. Continue will then triangulate that data, and I'm not editing this in any way. This is all occurring real time. The triangulation has completed and we can now see the contours being displayed. We select DTM display, turn off the dots, and let's change the contour interval to something more reasonable for this data. Query status will show us that there are 1.71 million points in this file. We return to large data sampling. We select all of the Esri ASCII grid files, and this time we're not going to limit the area of conversion, we're just going to import potentially all of the tiles. And whilst 3.2 million points can be loaded into a single LSS survey, what we may be able to do is, for much larger data sets, reduce the cell size. By resampling at 100 meter interval, we're going to reduce the number of points by a quarter. Imagine within each of those 100 meter square cells there will be points from the original 50 meter grid, and we can choose whether we want to keep the lowest or the highest of those points. And hit the Generates button. That will go through the whole data set, resampling at 100 meter interval. And we will be left with just over 800,000 points. Finish will allow me to load the data into an LSS load input file, generate a new Esri ASCII grid file containing all of the points. I'm going to choose LSS load input file, which will save and load. Now this capability may be useful if, for example, you really wanted 10 meter grid data but have been given 2 meter grid data, but you're happy just to take every fifth point along the eastings and then every fifth point along the northings. We now zoom into a smaller area and turn on the points and query a distance. We will see that the new distance is 100 meters and not 50 meters. And finally, returning to large data sampling. Again, we're going to add all of the Esri grid files. We're not going to restrict them geographically. We're not going to resample the grid, but this time we're going to use the thinning option. Now, thinning is a much more intelligent way to resample larger data sets. But the important thing here is that it will only work on data sets which have fewer than 10 million points. If your total data set has more than 10 million points, then you either need to resample it or restrict the geographical area so that you are looking at less than 10 million points, and then you can run through the thinning and then reapply the thinning to the remainder of the data. So you may need to break your data up into smaller packets if this number at the top exceeds 10 million. What thinning does is prompts the user to choose a vertical thinning tolerance. Let me explain this in basic terms. If you take all of the points that you've been given and produce a digital terrain model, then it will create triangles between those points. And as you move the cursor through that triangulation, you will get a level real time. If you were to use the thinning option and put a vertical tolerance of, for example, 0.1 of a meter, what this will do is it will take points out of the data set which, when removed, will result in a terrain model that is within ± 0.1 of a meter in level when compared to the model with all of the points in it. So what I'm going to do is go through this vertical thinning tolerance process and then come back and process the whole survey, and we can do a comparison between the two. We can always set a maximum horizontal spacing between points that are left, and you might use this for areas of water where you do want a point every so many 100 meters. We now select Generate, and it will perform the thinning task on the whole dataset. The process is complete, and it's now redisplaying the created thinned DTM. Please be patient while it's displaying the survey. We need to let it complete, otherwise the thinning process will be interrupted. And to complete the exercise, we select Finish, and we can see from the 3.2 million original points we've now got 1.6 million. And if we zoom in, you will see that there are now holes in this data. To make it a bit clearer, I'm going to increase the size of the points. These are the holes where points are not required in order to maintain the quality of the resultant thinned DTM when compared to the unthinned data. And if we were to draw a section through the thinned model and also the unthinned model, through these areas where there are now points missing, we will see that there is no difference in the DTM, or where there is a difference, it will be a minor difference which will equal the tolerance that we have previously defined.